Okay, please turn your paper over to the study guide side. It says finding and approximating squares and square roots. Okay, something to point out here is that a negative sign is used to indicate a negative square root. So if you have negative on the outside of a square root symbol, or a radical, then the answer is going to be negative. So for now, 36 is 6 times 6, so it's 6, but there's a negative on the outside, so the answer is negative 6. Now I did put some numbers, squares over here on this side here, square numbers. So this should be able to help you. Let's go to number 1. Okay, please don't write an answer. Kind of work this through. So square root 9. 9 is 3 times 3. So a pair of 3's can jump out. So my answer is 3. All right, move on over. Square root 25. That's 5 times 5. 25 is 5 times 5. Pair jumps out. Your answer is just 5. Number 3. Now, there's a negative there, so our answer is going to be negative. But 4 is 2 times 2. Okay, pair of 2's can jump out, so my answer is 2, but there's a negative in front, so my answer is negative 2. This is almost like saying negative 1 times square root 2. That's pretty much what it's saying. Okay, and then the fourth problem, 64. Well, 64 is 8 times 8. So you have a pair of 8's that can jump out. So the answer is 8, but there's a negative in front, so it's negative 8. Okay, slide back over. Number 5. 121. Now, if you don't know your numbers very well, you can simply look over to the side, and you find 121. There's 121, and that's 11 times 11. So that's there to help you. But most of you already know this. So 121, that's 11 times 11, which is 11. And that is it. Okay, number 6, 196. If you don't know that one, slide on over. Take a look. Find 196. Hey, 196 is 14 times 14. 14 squared. 14 times 14. So 196, is 14 times 14. Okay, there's a negative in front. So that means that 14 times, so that's just 14. You got a pair. Pair of 14s can jump out. And there's a negative on the outside, so it's negative. Number 7, 225. Can you find 225? 225 is 15 times 15. 15 times 15. So pair can jump out. 15, and that's our answer. Next, 144. Number 8. 144. That's 12 times 12. Right? So you have a pair of 12s that can jump out. Slide all the way over. 900. 900. What could that possibly be? Well, I know 9 is 3 times 3, so it must be, isn't it 30 times 30? Because 3 times 3 is 9, and 2 zeros makes 900. So it's 30 times 30. So you got a pair of 30s, they jump out, the answer is 30. Next one, 324. Is that on your list? Yes, it is. 324 is 18 times 18. It's 18 squared. So it is 18 times 18. There's negative on the outside, so the pair jumps out. And there's negative on the outside, so it's negative 18. Number 11, 300. All right, this is going to take some breaking down. Let's see, I know it's 3 times 100. I'm going to try and write small because I know it's going to take a lot of room. Now 100 can be broken down. Okay, so I got a 3 there. Now 100 is, well, let's do 2 times 50. 2 times 50. And 50, that can be broken down. 3 times 2 times 50 is 2 times 25. 2 quarters. Okay. Let's keep going. We have a 3, a 2, a 2. 25 can be broken down. 25 is 5 times 5. Okay, so now we need to take out some pairs. What do we have here? Looks like I have a pair of 2s and I have a pair of 5s. So they can both jump out. What will I have left inside? A square root 3. So my answer is, I'm just going to put this right over here. I'm going to have a square root 3 on the inside, and on the outside, I have a 2 and a 5. 2 times 5 is, you know what, I'll write it this way. I have a 2 and a 5. So my answer is 10 rad 3. Because these pair jumps out, a 2 and a 5, and you multiply those together, that's 10. Wow, that's a long one. Okay, number 12. Oh my gosh, same type of problem, square root 100. You know, make things easier, you could just use 4 times 25, 4 quarters. And I know that 4 is 2 times 2. I know that 25 is 5 times 5. So I have a pair of 2s and a pair of 5s. They jump out. And what do you have? 2 times 5, or just rather 10. So my answer is 10. Hey, wait a minute. What am I doing? I could have just went 10 times 10. That's crazy. I could have just said this is 10 times 10. Square root of 10 times 10 is, pair of 10s jumps out. I took the long way. Wow, what a waste of time. Okay, down below it says, find the best integer estimate. We're estimating for each square root. Then check your estimate. No, forget about that. We're not going to use a calculator. All right. Okay, we're going to write down 2 numbers and then our answer. So square root 37. Well, we know that square root 36 is 6, right? Because that's 6 times 6. We know that square root, let's see, what's the, 6, okay, 49 is 7. Is that right? Because that's 7 times 7. So where is 37? What's that closest to? Is it closest to 49 or 36? It's closest to 36. So that means our answer is going to be approximately 6. Oh, wait a minute. There's a negative there. So it's about negative 6. And that's our answer. So if you do this in a calculator, square root 37, it's about 6. Let's go to number 14. 90. Well, we know that, let's see, square root. Okay, we know that square root 81, is 9 times 9. Let's see, 10 times 10 is 100. Square root of 100 is 10. So what is 90 closest to? Is it closest to 81 or is it closest to 100? It's closest to 81. So that means this number right here, it's approximately 9. Okay, it'll be like 9.4 something, but it won't be past 9.5. Just to prove it to you, if I press 90 and then square root, look at that, 9.48. So see, it's closer to 9 than it is 10. It's closest to 9. Okay, let's see, we know that 49 is 7, right? Because 7 times 7 is 49. So square root of 49 is 7. And the next one, let's see, square root 8 times 8 is 64. So it's 8. So it's either closest to 7 or closest to 8. What is 50 closest to? 49 or 6? It's closest to the 49. So it's going to be closer to 7 than it is 8. And actually we got a negative here. So it's approximately negative 7. Next one, square root 300. Hey, we're going to have to find our little chart here, to use our chart to help us. Square root 300. Excuse me, so 300, where is that at? That's right, let's see, it's between 289 and 324. So, square root 289 is 17. So square root 289 is 17, and square root 324 is 18. This is 18 times 18, this is 17 times 17. So, where does 300? What's that closest to? Is it closest to 289, or is it closest to 324? Well, it's only 11 away from here, and it's 24 from here, so it must be closer to the 17. So it's about 17. And if I square root 300, I get 17.3. So we're estimating without even using a calculator. 75, let's see, we have 8 times 8, which is 64, right? That's 8 times 8, 64. And then 9 times 9 is 81. So what is 75 closest to? 81 or 64? Let's see, it's 11 away from 64, and it is 6 away from 81. So it's closer to 80. It's closer to the 9 than it is the 8. So it's approximately. Oh wait, there's a negative in there, so I'll say negative 9. Okay, 69. I know that it's 8 times 8 is 64. That's 8 times 8, and 9 times 9 is 81. So is 69 closer to 64 or 81? Well, obviously it's closer to 64. So it's closer to the number 8. So it's about 8. Okay, 375, I have to look at our chart. So looking at our chart, I have 19 times 19, that's 361. And then I have 20 times 20 is 400. So 375 is square root of 361 is 19. 19 times 19. Square root of 400 is 20. 20 times 20. So what's the 75 closest to? The 61 or the 400? Closer to 61. So it's closer to 19 than it is 20. So it's approximately 19. Number 20. Now this says 27.9. So just think of it as being 28. Okay, just round it off. So square root of 28. Well, we know that 5 times 5 is 25. Okay, so that's 5. 5 times 5. And we know that 6 times 6 is 36. So what is 28 close to? Is it close to 25 or 30? It's close to 25. So it is approximately 5. It'll be 5.2, something like that, 5.3. And the last one there, again, round it off. That's closest to 11, negative 11. And so we have, let's see, 3 times 3 is 9. And we know 4 times 4 is 16. Okay, 4 times 4 is 16. So what is it going to be? Is 11 closer to 9 or 16? It's closest to 9. So that means it's closer to the number 3 than it is to 4. The square root is. So it's approximately, oh wait a minute, we're talking negative, so it's approximately negative 3.